Hello, everyone. I'm Steve. Scott's laughing because Baba, you can hear Baba in the background. Rotten cat, you little alley cat.
God, and I am laughing.
I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, and we got Baba too. Apple Valley, California.
Science and Technology Channel.
And Baba is the expert. He sniffs everything. Okay. NASA's AWE mission, AWE, just released millions of gravity wave images from space, unveiling atmospheric forces that ripple through the sky and affect our tech on Earth. It's a whole new window into space weather. After completing its 3,000th orbit aboard the International Space Station, NASA's Atmospheric Waves Experiment, AWE, has released its first set of scientific data. This milestone marks a major step in studying how subtle changes in Earth's upper atmosphere can lead to disturbances and how these disturbances can affect technologies like satellites, communication systems, and GPS on Earth and in space. Would you like to know more?
Yeah, this is pretty important stuff, right? I mean, this
Yeah.
is this could be this could be ugly.
Satellite phones, regular phones, GPS, you name it.
Computer stuff, right? Anything
Yeah.
computer. Yeah, that which I mean, what do we not have today that's not run on some kind of a computer system? So
Ham operator radios.
yeah. Now available online, the data set includes over 5 million images of nighttime airglow and atmospheric gravity waves captured by AWE's 4 onboard cameras. It also contains processed data showing temperature patterns and airglow intensity, offering insight into the surrounding air and the improvement of the waves.
Quote, AWE is providing incredible images and data to further understand what we only first observed less than a decade ago, said Isaias Shum, AWE program scientist at NASA headquarters in Washington. Quote, we are thrilled to share this influential data set with the larger scientific community and look forward to what will be discovered.
Atmospheric gravity waves are naturally occurring features of Earth's atmosphere, shaped by weather systems and the planet's terrain. While scientists have studied these waves for years, observations have typically been limited to a few ground based locations. AWE now enables a much broader space based perspective. So, cool.
Quote, with data from AWE, we can now begin near global measurements and studies of the waves and their energy and momentum on scales from tens to thousands and even thousands of kilometers, Shearley said. This opens a whole new chapter in the field of research.
Data from AWE will also provide insight into how terrestrial and space weather interactions affect satellite communications, navigation, and tracking. Quote, we've become very dependent on satellites, that's an understatement, for applications we use every day, including GPS navigation, Shearless said. Going on with the quote, AWE is in an attempt to bring science and about atmospheric gravity waves into focus and to use that information to better predict space weather that can disrupt satellite communications. We will work closely with our collaborators to better understand how these observed gravity waves impact space weather. So,
Okay, the tuba shaped AWE instrument, known as the Advanced Mesospheric Temperature Mapper, or AMTM, consists of 4 identical telescopes. It is mounted to the exterior of the International Space Station, where it has a view of Earth.
as the space station orbits Earth, the AMTM's telescopes capture 7,000-mile long swaths of the planet's surface, recording images of atmospheric gravity waves as they move from the lower atmosphere into space. The AMTM measures and records the brightness of light at specific wavelengths, which can be used to create air and wave temperature maps. These maps can reveal the energy of these waves and how they are moving through the atmosphere. Pretty cool.
To analyze the data and make it publicly available, AWE researchers and students at USU developed new software to tackle challenges that had never been encountered before. Quote, reflections from clouds and the ground can obscure some of the images, and we want to make sure the data provide clear, precise images of the power transported by the waves, Shearless said. We also need to make sure the images coming from the 4 separate AW telescopes on the mapper are aligned correctly. Further, we need to ensure stray light reflections coming off the solar panels of the space station, along with moonlight and city lights, are not masking the observations.
As the scientists move forward with the mission, they'll investigate how gravity wave activity changes with seasons around the globe. Phyllis looks forward to seeing how the global science community will use the AW observations. Quote, data collected through this mission provides unprecedented insight into the role of weather on the ground on space weather. End quote. AW is led by Utah State University in Logan, Utah.
Boop, boop.
Yeah, and it is managed by the Explorers Program Office at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Utah State University's Space Dynamics Laboratory built the AW instrument and provides the Mission Operations Center.
Really cool.
The other day we were doing a story with Goddard that involved NASA's Goddard Space Flight Center, and I'm trying to think where they came up with that name. I don't know if that was a name of a scientist, or if that's a name of a lake or an area. And I meant to do some research, but now I'm going to do that. So it's like that name Goddard sounds very familiar to me. So, but anyway,
folks, if you know where it came from, let us know in the comments.
Yeah, save me the research. Take care, everyone.
All right, we'll catch you on the next one.
Thank you. Have a good day.